Okay, on to Unit 7. Here we are looking at, this actually is a typo up here. This, as you probably have figured out, Unit 7 is actually inverses. And the first question here is find the inverse of the function given by these 4 points. This is a simple function, 4 inputs with 4 outputs. And essentially everyone hopefully knows that that inverse function is like hitting the undo key. So we need a relationship where normally for a function you put an input in, out comes an output. Well, the inverse undoes that. So we start with the output and it gives us back the input, even though the output is the input, if you see what I'm saying here. So essentially we just need to reverse the x and y coordinates here. So input of 1 gives us 5, negative 1 gives us 2, 2 gives us 10, and 5 gives us 4. That's the normal function, we'll call it f. And then f inverse is the undo function. So we need something, if we put 5 in, it gives us 1 back. If we put 2 in, it gives us negative 1 back. If we put 10 in, it gives us 2 back. And if we put 4 in, it gives us 5 back. And so that's the inverse function. And if we were going to write it in the same notation here, we would just write these as ordered pairs to indicate what's going on here. 5, 4, and put some brackets around it. And this right here represents the inverse function. Notice how you could simply think of this as just switching the x and y components. So all the inputs become the outputs, and all the outputs become the inputs. 32, this is just a question about making sure to understand this notation here. So we use this, looks like raised to the negative 1 power, but in the context of here, so if we have a function f of x, remember f is the name of the function, and this tells us the input. If we write f negative 1x here, this does not mean raised to the negative first power. This is just simply a way of writing the word f inverse. So when you read that, you say f inverse of x. Sometimes when we do things to the negative power, like 3 to the negative 1 power, that means 1/3. So it's like it's an exponentiation with a negative number, or x to the negative 6th power equals 1 over x to the 6th. That's not what's happening with that inverse function. And so what's happened to the student here is they basically misinterpreted. They said, oh, inverse must mean take the reciprocal. So what they did here is they took f of x equals x squared, saw that raised to the negative 1 power, and said, oh, that just must mean take the reciprocal, which is the wrong interpretation here. So again, just remember when we're talking about functions, this means inverse. You probably have seen this on your calculator too if you've taken physics, or remember from geometry. Remember there was a sine function, and there was also a sine negative 1 function, which was the inverse sine function. The same thing would have been with cosine negative 1. Those negative 1s on your calculator, when you see those written, have mean inverse, which means undo, and tells, normally for the sine function you put an angle and it gives you a number. Inverse sine is you give it a number and it gives you back the angle. So for inverses, we're trying to write a function that does the undoing. So for this one, think about what we're doing with this function f. We're taking an input and multiplying it by 4. So to undo that, we would have to divide by 4, take whatever the output is and divide by 4. So we can reason through that the inverse of this function must mean take a number and divide it by 4. Similarly here, this is taking an input and subtracting 7. Well, to undo that, we would need to add 7. So for b here, the inverse function is going to be take the output, we'll call it x, and instead of adding or subtracting 7, we're going to add 7 to undo what's going on here. Here, this is taking an input and dividing by 100. Well, to undo that, we need to multiply by 100. So the inverse function of c is take a number and multiply it by 100, or we just call it 100x would be the more typical way. D, this is taking a reciprocal, which is kind of like, as we talked about in the last unit, like flipping. Well, if you have a number like 3 halves, and you take the reciprocal, the way to undo that is to just flip it again, take the reciprocal one more time. So the reciprocal of the reciprocal function is, it's the same function itself. And the last one here is taking the cube root, and to undo taking the cube root, or you can also remember this is x to the 1/3 power, the way to undo that is to cube. So raised to the 3rd power, or you can see that x to the 1/3, all raised to the 3rd power will cancel out and give us x. So to undo cube rooting, we take the number and just cube it. Now all 5 of these could also be done with the more traditional method, which we'll talk about in the next problem. So if this approach is not something you're comfortable with or don't like, you could use the method I'm about to talk about on question 34 to do these as well. But I like to think that using this reasoning approach is more ideal here, because then it's more clear what this inverse function is actually doing for you. It's a function that you tell it the output, put that here in these x columns, and then it will tell you the input that came back, or that input that you started with. So 34 here, I'm just going to outline the steps of doing the algebraic process of finding the inverse. I'm going to do it for one or probably 2 of them, and then you can look at the answer key for the rest, but I don't think I need to go through the process for all of them. So just as a reminder of the process, step 1 is to replace f of x with y, so we can work with it more easily when we do the algebraic manipulations. The second is just like when we've done in that very first problem. To do inverses, we're going to switch the input and the output, which means switch the x and the y in our equation. Next, we're going to solve for y, and then when we're done with that, we're just going to relabel y and say replace y with the symbol f inverse of x. Okay, so this is the algebraic process that will work for all of these, and let's do this. Go ahead and do this for a first here. So a, step 1 is replace f of x with y. So step 1 would be to call it y equals x plus 3. Step 2 would be to switch x and y, so we're going to rewrite that as x equals y plus 3. Step 3 is to solve for y. Here we're going to do that by subtracting 3 from both sides. We'll leave y by itself. Y equals x minus 3. And then the 4th step is to replace y with f inverse of x. And notice how we started with a function that added 3. Our inverse function is subtracting 3, so that kind of hangs together with what we would have expected from an intuitive sense from that last problem. And let's see, let's do one more here. Let's do the next one. We'll do b. So b is, the function is, take the cube root of x plus 3. So step 1, replace y, or replace f of x with y. Step 2 is switch x and y. Now we have to solve for y, so the idea is we've got to unpack y. How do we get to it? Well, we've got to undo all these operations that are around it. So the first thing we're going to do is cube everything. To get rid of that cube root, because that's how you undo that. So cube root, which is a cube both sides, will give us x cubed on the left, y plus 3 on the right. Now we have to solve for y by subtracting 3 from both sides. Y equals x cubed minus 3, and then this is all step 3 here. Step 4 is just replace the name. Inverse of x equals x cubed minus 3. So let's just see if that works for us here. If I take a number like 5, so we put x equals 5, put that into this function, 5 plus 3 is 8, cube root of 8 is 2. So f of x equals 2. So let's see, if we put 2 into this function, we get 2 cubed minus 3, which is 8 minus 3, which is 5. So it looks like that inverse worked. We put 5 in initially, okay, 2 came out, we take that 2, put it into the inverse function, 5 comes back. So the undo was successful. Again, so these next, you need to see the process for these last, the second quarter. Actually, I don't even think I did this one. It's called that challenge gone. But C through F is on the answer key, and it's all written out step by step. So hopefully with this video and that answer key, you can find what you need.